Okay, so let's talk about the unit circle. So before we start, we need to talk about or review a little bit our special right triangles. And we're going to manipulate these a little bit. All right. Okay, so let's start with the 30, 60, 90. So when we do the right triangles, so our sine, cosine, and tan, we need ratios, right? And so what can actually happen is I can double all these sides and the ratio will be the same, right? I can triple all these sides and the ratio would be the same. Or I can half all these sides and the ratio would be the same. So the key to this is I can pretty much do what I want, multiplication or division, to any of these three sides as long as I do the same thing. So what we're going to do is divide all the sides by 2x. So I'm going to take this hypotenuse and divide by 2x, and it'll become clear why we do this in a second. Because again, I can divide by whatever I want. So dividing by 2x is actually going to be extremely helpful. All right. So the next one, I have x rad 3 divided by 2x, and then x divided by 2x. So I just divided all the sides by 2x. And the reason I wanted to do this is because 2x divided by 2x is 1. Now the hypotenuse is 1. Okay, and so right now too, it's not clear why this is helpful, but it is very helpful. And then notice what happens to the other sides, right? X divided by x, that turns into a 1, right? So anything divided by itself is 1, so I'll just have rad 3 over 2. And then x divided by x, that turns into a 1 again. So that's how I have a 1 on top for the 1/2. And now look what just happened. I have two wonderful things that happen. The first is the hypotenuse is 1. Again, not clear why that's important, but it will be in a second. And the other is, look at the sides. I no longer have x's anywhere, right? I don't have to worry about the x's anymore. I just have straight numbers, which is nice. All right, let's try the same thing with 45, 45, 90. So again, I want the hypotenuse to be 1, so I'm going to divide everything by x rad 2. Okay, again, I can divide by whatever I want, but this is the most helpful for this context. So divide by hypotenuse by x rad 2. Divide the sides, right? So x divided by x rad 2. And then this one's the same, so it'll be x divided by x rad 2. All right? And then what happens? Same thing as before. The hypotenuse turns into a 1, because anything divided by itself is 1. The x's on this side, the vertical side, will divide out to be 1, so I'll get a 1 over rad 2. And then these x's divide out, so I'll get a 1 over rad 2, which we knew, right? Because they're, again, going to be the same value. And then that's it. So mathematically, 1 over rad 2 is fine, right? There's nothing wrong with that. Well, again, you're in high school algebra, so we're going to rationalize this denominator. So you'll see it as, so 1 over rad 2, I can multiply by rad 2 over rad 2, and that'll be a rad 2 over just 2. Okay? So I'm going to change my 1 over rad 2s into rad 2 over 2s, and that's what you'll see on these sides. All right? So it's the same thing, it just, all I did was change the way it looks, but I didn't change the value. All right? Those are our two new versions, I call them, of our special right triangles, right? The new version such that the hypotenuse is 1. And all the x's are no longer in the sides, right? All right, so I want to stop this and complete class or problem number 1. Okay, so now I just want to show you that either version of the special right triangles will be the same. So let's do sine of 60 using both versions. So the first one is with all the x's in it. So opposite 30 is x, opposite 60 is x rad 3, and hypotenuse is 2x. Well, sine of 60 is opposite, so x rad 3 divided by hypotenuse, 2x. And again, what happens? The x's divide out, so they turn into a 1, and so it's 1 times rad 3 over 2 is rad 3 over 2. Good. And choose our new version. So our new version is hypotenuse is 1, opposite of 30 is a half, opposite of 60 is rad 3 over 2. Sine is rad 3 over 2, all divided by 1. But anything divided by 1 is itself. So sine of 60 is just this side. There you go. And we're done. So you can see what happens. I don't have to do this simplification, right? I just can look at the triangle, and since the hypotenuse is 1, sine and cosine, sine will be this, cosine will be this of 60. If we did sine of 30, it would be this value. Cosine of 30 would just be adjacent this value. All right, so it really simplifies things quite a bit. All right, so you want to stop this and do class or problem number 2. All right, so now one thing we can use this new kind of version of this right triangle, and I say that where the hypotenuse is 1 is in what's called a unit circle. So if I threw up my right triangle in here, this just means that the hypotenuse is 1, so the length of this line is 1, and then the x's and y's mean that these are just arbitrary, right? So x and y can take on any value as long as this stays 1. right? Which means, I can move the horizontal component of this triangle can be, long, short. It could be longer or shorter. It could be in this direction, the negative x direction. Again, the y can be longer or shorter. So I can have triangles that fill up this whole thing. I can do triangles all over the place. That's what this generic x and y do for me. And in fact, if I do that, the hypotenuse always has to be 1. My triangles have to fit in this circle, right? So draw a triangle in the second quadrant. I'm always going to put the first part of the hypotenuse at the origin, and then I'll extend the hypotenuse out until I hit this line. Because since this is a circle of radius 1, that means the hypotenuse would be 1. Then I drop it straight down, so I can do that anywhere. Come here, origin, go straight to the edge of the circle. That means the hypotenuse is 1. Go to the x-axis, right triangle, you're good. Okay, so now that I know this, I know a few things. Well, on the positive x-axis, since it's a radius of 1, then I know this ordered pair right here is x1, y0, because it's a positive x-axis. Right? So at 0 degrees, I get 1, 0 for the x and y component. Well, for the 90 degrees, right, I'm going to get 0 for the x and 1 for the y, because again, it's a circle with a radius of 1. Now I'll go in the negative x direction, so at 180 degrees, I'll get an x of negative 1 and a y of 0. And then lastly, at 270, I'll get a negative y, so I'll get an x of 0 and a negative y of 1. All right? And then anywhere on this circle, right, which I haven't written here, but I should have, this point will be xy, right? It'll be in the x direction and the y direction, so the ordered pair right here is x, y. All right? Okay, well, we know some other stuff here. We know that y, if we wanted to, sine of theta equals opposite y over 1. Right? So y over 1, anything divided by 1 is itself. So this is really just sine of y. So I know the height of this triangle is actually just sine of whatever that angle is. And that'll give me the y coordinate of this point. Well, I can do the same thing for cosine. Cosine is adjacent, which is x, divided by hypotenuse, which is 1. And then the hypotenuse, since it's 1, x divided by 1 is x. And I'll get that the x is actually just the cosine value of that angle. Again, so this simple relationship here, that the height is sine and the width is cosine, comes about because this hypotenuse was 1. It simplifies our math quite a bit, which is why getting that hypotenuse of 1 was really helpful. All right? All right. So now what I can do is, a common thing is to kind of fill out the unit circle for the angles that we know. And what are the angles that we know? Well, our special right triangles. Right? We already have, I should point out, ordered pairs for all of these, right? For all the axes. Here's 1, 0, 0, 1, negative 1, 0, 0, negative 1. So at the axes, I already have ordered pairs. But now I can do my special right, so I can do 30, right? And then you'll see later, I'll have 60 or 45, I'll have 60, and then I'll have all those reference angles all over the place, right? So if I were to do 30 degrees, start at the origin and go 30 degrees as for this line, then the ordered pair right here would be rad 3 over 2, comma 1/2. Right? That would be the ordered pair, just like the ordered pair here is 1, 0. Right? Now, how do I know that? That's the question. Well, this is a 30-degree line, which means I can do a 30-degree right triangle. Well, if it's a 30-degree right triangle, then I know that's 60. Well, there you go. Now I have 30, 60, 90. Now, what I need here, remember, now that I have 30, 60, 90, I have two versions of this triangle, the special right triangle. I want the version such that the hypotenuse is 1. So I want that to be a 1. And now this is, again, we have to go kind of memorize again. So opposite 30 is 1/2. Opposite 60 is rad 3 over 2. And there you go. In the x direction, it's a distance of rad 3 over 2. In the y direction, it's a distance of 1/2. So that ordered pair is rad 3 over 2, comma 1/2. All right? And that's exactly what we're going to do. So if I show you the kind of complete, well, it'll be on your classwork. We're going to just keep going around the circle and do our special 30, 60, 45 degree angles. All right? Okay, and that's exactly what the last part was. So that's the end of the video. You want to complete class or problem number 3.